So what is intensive and extensive property? Intensive and extensive properties, or what are these variables? Let us consider in this way. Suppose you are having an ideal gas taken in a container. Right. And now suppose I am taking three different imaginary boundaries like this one, even bigger. Imaginary. These are not real boundaries. Suppose some imaginary container exists like this within a system of ideal gas. Now you tell me, what are the variables which will remain fixed in either in these three? So ask, what will be the pressure here? P. Then what will be the pressure here? Will it be different or same? Answer is same. P. Here P, because P at every corner will be same. So anything which is sample size independent is known as intensive variables. Intensive means sample size independent. Or extensive means sample size dependent. Right. So when it comes to example, when I'm saying intensive and here extensive, mole will come here because different mole will be there in this mole, mass, volume, any energy term. Why? Because energy directly and indirectly related with mass. Like one of the way you can see that what is the cumulative equivalent of energy of this mass. So you know E is equal to mc square. Look at the mass term is there. और अगर आप काइनेटिक एनर्जी भी निकालना चाहते हो तो जितने ज्यादा पार्टिकल्स उतना ज्यादा काइनेटिक एनर्जी. So all the energy terms, kinetic, potential, total energy, enthalpy, Gibbs, right? All of these. Even अगर आप तो entropy is associated with dq by t. तो आप देखो it is directly related और ये extensive नहीं है. T is an intensive variable. So extensive upon intensive is always extensive, right? अब वैसे भी देखो it depends on, so that will also fall this category. Now, ये pressure will come, density will come also. With the density at this point, this point, this point, every time it will be same. Anyway, if you write density as mass by volume, then the ratio of two extensive variable becomes intensive. So like that, if I'm saying enthalpy, it is an extensive. Enthalpy per mole, it became intensive. Now, ऐसे ही अगर मुझे बात करना हो तो हीट कैपेसिटी पे बात करते हैं. व्हाट डू यू अंडरस्टैंड बाय हीट कैपेसिटी? तो हीट कैपेसिटी इज डिफाइंड एज how much heat is supplied to change the temperature of the given mass per 1 degree. Now, Q divided by delta T. This is heat capacity. So this is extensive because bigger the mass, bigger will be the energy required. Right? But when I'm saying that is extensive. But when I'm saying heat capacity नहीं, specific heat capacity, Q divided by M delta T, then this is extensive upon extensive. This will be intensive, right? And similarly, molar will also be ex intensive. Now moving to the next, like how to decide whether molarity. Now look at this. Suppose a solution is made by mixing NaCl into water. You know that the ions will be dispersed uniformly. And if they will be dispersed uniformly, number of mole of NaCl per unit volume at any part will be same. No matter whether you are taking a sample size over here or over here or over here, everywhere the molarity will be same. So molarity is an intensive, or otherwise you can see like this, number of mole of solute upon volume. This is how the molarity is defined. So the ratio is always extensive to extensive, which becomes intensive. Right, so that's all about extensive and intensive variables. Like one of the very important thing is EMF. How would you say that? EMF. This is really, really important. So for telling this, you need to know this relation delta G minus time of delta G is equal to NFE. When it comes to E, this is basically delta G upon NF. Now you know that this is extensive. This is also extensive. So overall ratio of extensive becomes intensive.
So guys, if you want more videos like this, like, share, comment and don't forget to subscribe.